Welcome to the 820. This week we're talking about the PSOC5 LP. This is a Cypress, now Infineon development kit for a microcontroller. Now I've also got an Adruno microcontroller. I'd like to explain my motivation for looking at the PSOC first in this series. So this is the patent which introduced me into photonics years ago, and I want to replicate some behaviors with this and learn how EO crystals work, electrical optical crystal. So in this patent, this particular crystal was changing the polarization of light due to the voltage across it. So I'm interested in controlling the voltage at the top where the V is, that little circle. And so I want to be able to control that voltage with a microcontroller. The Adruno has an analog input, so I could look at the signals at X or at Y, but not at both at the same time without additional components. The Cypress module has enough hardware inside it to do all three. So let me show you that. So here's the block diagram of the PSOC microcontroller. At the bottom of this diagram, we have an analog subsystem. There's 4 digital to analog converters, so I can supply 4 different voltages. It's like having 4 power supplies on my bench. Additionally, there's some analog to digital converters and some op amps, so I can replace these other objects from the schematic with just this single device. The digital to analog converter will provide a controllable voltage at the top of the electrical optical crystal here. And the Adruno didn't have a digital to analog converter, so I couldn't do this. The Adruno did have an analog to digital input, which I could have used here, or I could have muxed it and used it at the other location, but the Cypress chip allows me to do both simultaneously. And be able to replace this differential op amp with the op amps programmable in the Cypress chip, I think, is the icing on the cake. So the first step is to go to the Cypress website, and then it redirects you to Infineon because they were bought out. And then you have to go download the PSOC Creator, and then once you get through that, you can fire up PSOC Creator and begin, which is kind of cool. They have a lot of example projects, and they have a lot of documentation there, so that's nice. So I just opened this up and I'm playing with it. And the top left, I have my analog, that's my voltmeter, my analog to digital converter. And then at the bottom right, I've got my DAC, which is my power supply, if you will. And then I also have an LED driver, which will drive my voltmeter display. And I'm going to use the Arduino's LCD that I already bought for the voltmeter display for both the voltage setting on the power supply and for when I read things. And when I build that kit, I will share that. I'll probably have a part number for just the display, so you don't have to spend $80 to get the Adruno just for the LCD screen at this time. So at this point, I've just sort of dabbled with it. I think I'm going to have to use example projects to understand the programming. But this was the Amazon page I purchased, and then I'll show you the box that I got it in. The front of it came in the mail, and then the back. So actually, there's no manual or software. You just go to the link there on the bottom, cypress.com CY8kit, and download the software, and you can start working with their software right away. So I'm kind of stalled because I'm trying to look at electrical optical crystals. I want to see how they affect polarized light. And so there's various components I needed. First, I needed a polarizer to polarize the light linearly, and I thought I'd ordered one of those and it was waiting for it, and it turns out it didn't get shipped. So it shipped like yesterday, and I ordered it a month ago. But the quarter wave plate that I ordered did arrive, and that was ordered at the same time from the same vendor. They just shipped the wrong thing first. I mean, if I'd gotten the polarizer first and the quarter wave plate second, I could still do experiments with the analyzer. And I need at least this much of the material to experiment with the polarization of light. By now, I was hoping to have enough of the material to do at least some polarization experiments and maybe some experiments with crystals. So initially, when I started the channel, I thought, hey, EO crystals are where it's at. That's what I need to look at. And I needed to get my hands on some lithium niobate crystals. Now I've got some transceivers, optical transceivers, but my guess is 90% of these are just laser drivers and they don't have crystals in them. Found this out by finding a FinSAR datasheet, and it showed the laser driver instead of an EO crystal. This Fujitsu modulator, I believe, does in fact have a crystal in it, but I couldn't find a datasheet on how to bias it. It's sort of top secret, and I don't want to crack it open just yet. So I found another source of lithium niobate crystals. So AliExpress seems to be the cheapest source I could find. Of course, I haven't gotten them yet. But you can buy all these different sizes, and I'm getting the long rectangular sliver size. And I've got some ordered, and they'll be in probably in the next 6 months. And it was $16, so much cheaper than eBay, or I could buy a lithium niobate wafer for $200 on eBay. But if I got that, then I have issues. I really need to slice it, or I'm gonna break it. I don't have the tools to manage a wafer right now. But I may at some point decide to blow $200 on a wafer that might not do anything. I'm just not sure I'm there yet. So there are options. If I want to spend up towards $1,000, I could get a lithium niobate crystal from eBay. But again, like I said, I don't know what I'm doing. I'm trying to explore, so I don't want to spend a lot of money. I don't want to throw a lot of money away while I'm exploring. So I'm just looking for cheap ways to look at this crystal interacting with the polarization of light. That's sort of a recap of where I'm at. I wanted to talk about some YouTube videos on photonics that I've seen recently that I need to rewatch. This one is from Harvard University. This Marco guy is, of course, a genius, and they are founders of a company called Hyperlight, and they've been able to do some amazing things. That first talk here talks about lithium niobate advances that they're doing, and also some interesting quantum memory ideas. Basically, they talk about the ability to make a memory cell being just the spin of an atom and moving the spin of the atom to change the bit by using laser light and RF frequency. It's mind-blowing. Photon dynamics patent that I'm talking about from 1995 was able to digitize 1 volt swings using electrical optical lithium niobate crystal, and I don't know that they use the high voltage bias, but typically what I've read says that EO crystals take 30 volts to 100 volts to 1,000 volts of bias, but that's not what the IEEE paper for the photon dynamics circuit said. So I'm going to have to face that at some point. Final note, I thought, I'd like to buy stock in Hyperlight. It's privately held. A lot of the companies that do this work at this point are privately held.
Φως ταχύτητα.